in the equations that we saw yesterday, all of the terms were fractions, right? But if we look at this first equation here, what do we notice about all of the terms here? Are they all fractions here in this equation? No, only one of them is. But because one of them is, we're going to have to clear our fractions, okay? Thank you. So even though only one of my terms is a fraction, we still got to work to clear them all. So if I have a term that does not have a denominator, what can I put underneath that number? Does anyone know?
A 1.
A 1, exactly. So 3x turns into 3 over 1x, and negative 6 turns into negative 6 over 1. Now all three of my terms, term 1, term 2, term 3, they're all fractions. Now I'm going to do exactly what we did yesterday. So that's the only different thing today, is that if you see something that's not a fraction, put it over 1. Now, what are my different denominators here in this equation? Which denominators do I have here? 1 and 3. So let's find the LCD. What are my multiples of 1?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yep, and we can keep going and going and going, right? I'm glad you guys know how to count. That's awesome. What about 3?
3, 6, 9, 12.
6, 9.
Yep. 12, 15, 18, 21. So what's my LCD?
3.
3. That means we want all of my denominators to equal 3. All right? So if I've got, I'm going to go over this again just so I can see it better. If I've got 3 over 1, I got a 1 on bottom, I want a 3 on bottom. What could I multiply that 1 by to give me 3?
3 over 3.
3 over 3. Very nice. What about 4 thirds? 1 over 1. Yep. Already got the 3 that we want, so we can leave it alone. And 6 over 1? 3 over 3. All right. Now we just multiply it all out. 9 thirds x. Good. Good morning. Plus 4 thirds. It's been thinning. Yeah. I don't think so. I think I'm okay. Oh, do you have access to the ink for the Duplo in here?
Oh, I'll go ask them.
It's, yeah.
So ink for the Duplo.
Yes.
And that.
Yes.
Okay, I'll go ask.
Perfect. Thank you.
You're out?
Yeah, it's running pretty thin.
Okay,
Yeah.
I'll see what you got.
Okay, thank you. What was this last term over here? Beautiful. Negative 18 over 3. Now that each term has the same denominator, cross them out. Boom, boom, boom. And we've got 9x plus 4 equals negative 18. And we'll solve that just like normal. What do I want to do first? Subtract 4. What's negative 18 minus 4? Negative 14. Great guess. Negative 22, right? Again, if we have 2 negatives, it's just like having 2 positives. 18 plus 4 would be 22. So negative 18 minus 4 is negative 22. What do I want to do last? Divide by 9. What 2 numbers multiply to give me 22?
11 and 2.
11 and 2. What about 9? 9 and 1 or 3 and 3. Can I cancel anything here? No. So we'll leave it like that. Negative 22 over 9. Here's our answer. Not a pretty answer, but it's our answer. Negative 22 over 9. good. Let's take a look at some other examples of this. It's not too bad though, right? Just putting the fraction, or putting the whole number over 1. All right, for this first example, what's the very first thing I want to do?
Put a 1 underneath
Ex-
the 2 over 1.
Exactly right. Put that 2 over 1. Now I've got 1, 4, and 8. What's my LCD?
8.
8. What can I multiply 2 over 1 by that's going to give me an 8 on the bottom?
8.
8 over 8. What about 1/4?
2 over 6.
2 over 2. So now I've got 16/8 x plus 2 over 8 equals 6 over 8.
I think you're all those are like
Oh. You sure?
Oh, you don't need.
It's alright, don't worry about it. You just write this first and then glue it in later. What can I do with all my 8s now? Cross them out.
And then divide.
We're always going to divide last. Let's see. Let's take it slow.
Subtract.
Yeah, we're going to subtract 2, right? Then we can divide by what?
16.
16.
And then you use
So, let's see. I've got 4 over 16. Now you look at that and go, oh, that's going to be 4. But again,
16 over 4, then it would be
say that one more time.
4. So 16 over 4, then it would be 4.
Exactly, but because it's 4 over 16, what would it be instead?
16.
4 over 16? So let's think about it like this, right? Just like how we always do. What can I cancel out between the 4 times 1 and 4 times 4?
4.
Okay, so what am I left with?
Call 4.
1/4. So in your brain, you looked at that and went, oh, that's 4. But just like we see up here, if I have a 4, it's really a 4 over 1. So instead, it's just the other way around. Totally common. A lot of people make that mistake. They see that and they think, oh, that's just 4. We got to slow down, think about the steps, work through it, and we get our answer 1 over 4. Boom. Now, example number 2. I got 3, a 5, and a nothing. What's my nothing going to be? That was a weird way of saying that.
Over 1, 2 over 1.
Yeah, put the 2 over 1. So what's my LCD between 1, 3, and 5?
Maybe 5.
Well, does 3 go into 5?
Nope. So
No.
you
You have to write out all the multiples, right? Or we can just think about it, right? I mean, I know that 3 is 3, 6, 9, 12, 15. I know that 5 is 5, 10, 15. So what's my LCD going to be there? 15.
Yeah.
Okay, let me write this out. 1/3 x plus 2 over 1 equals 4 over 5. What can I multiply 1/3 x by? 5 over 5. How about 2 over 1?
15 over 15.
Nice. And 4 over 5?
3 over 3.
Perfect. Now I got 5/15 x plus 30/15 equals 12/15. Now that I see I've got 15, 15, 15, what do I do with those denominators?
Cross out all the 15.
Cross out the 15s. And I'm left with 5x plus 30 equals 12.
Subtract 30.
Good. Subtract 30. Get negative 18.
And then we would divide.
Divide by.
5 on both sides.
Good. Can I simplify 18 over 5 at all? No, I cannot. 5 can only be split into 5 times 1. 5 doesn't go into 18. So we leave it as 18 over 5. Negative 18 over 5. I'm going to leave that there for 60 seconds so you can finish copying it down. Let's see, I probably went too fast on that one. So get writing. I'll give you time. Should be enough time. Last one. What am I going to do with my 4 and my x?
Over 1.
Put them over 1. Now, what number's in front of my x right now?
1.
1. So we got 4 over 1 plus 1 over 1x equals 11 over 3. What's my LCD?
3.
3. Sorry, that's blurry. What can I multiply my first?
3. And then 3 over 3.
And?
And then 1 over 1.
Perfect. What am I going to do with my 3's now?
Cross all out.
Good.
Subtract.
See what we got. 12 plus 3x equals 11. Now, what am I going to subtract from both sides?
12.
12. Good. That constant term. Even though it's in the front, don't be fooled. 12 is my constant. That's what I'm going to subtract. What's 11 minus 12? I love that guess. If this was negative 11 minus 12, then yes, we would. But if I have $11 and I spend $12, what would that give me? Or we could think of it like this. My little negative and positive table. Which number is negative here?
12,
Okay, which number is positive?
11,
Which one's bigger, the negative or the positive?
a negative.
The negative, so my answer is negative. How much bigger is 12 than 11?
One more.
One more. Boom. Negative 1. 3x equals negative 1. Divide both sides by 3. X is equal to negative 1/3.